Today, our guest is Professor Kim Calders. He's a professor of Earth observation and terrestrial ecology at Ghent University in Belgium. His research interests are in terrestrial and UAV-based LiDAR, measurement and modeling of full 3D vegetation structure, and how this is related to airborne and spaceborne remote sensing signals and radiative transfer modeling. Thank you so much for being here today, Professor Calders.
Thank you for having me.
Yeah. Before we dive into your research, I think it would be helpful for our listeners if we first introduce some of the key terms and concepts that will come up in our discussion. So perhaps best to start with terrestrial laser scanning. So what is terrestrial laser scanning?
So terrestrial laser scanning is a remote sensing technique. It's an active remote sensing technique. So it means that we can use the instrument at any time of the day. So we're emitting laser energy, and the laser energy is being shot into the environment. So we work in forest, so it's been traveling in the forest, and when it hits elements in the forest, so it can be stems or twigs or leaves, it will send energy back. And it does that with a rate of like 100,000, 300,000 measurements per second. So by doing that, it's building up the 3D environment around us. So we're using it mostly from a tripod on the ground. So that's where the terrestrial term comes in.
So what is the difference between terms laser and LiDAR for people who are not in this research area?
Yeah, so you could sort of use them to as synonyms in some way. So LiDAR stands for light detection and ranging. So that's basically summarizing the concept that I just described. So basically it will emit some light when we use laser light, and then it will detect it, and based on ranging. So basically that it's another term for calculating the distance. It will actually find the points in 3D space.
Mm-hmm. So can you explain also the concepts of active and passive remote sensing, and what are the advantages of a LiDAR over other sensors?
Well, so the advantage of active remote sensing is that so we're emitting our own energy. So it means if we do a scan at night in the forest or during the day, we will always get the same data because we're not dependent on, for example, the sun. So when you take a photo with your camera of your phone, which is a passive instrument, if there's no light, if you take a photo in the dark, it will just be black. But with active instruments, there's no difference between when you take the data because you're basically emitting the light and receiving the light from the same instrument.
So when I was preparing for this interview and get to know more about LiDAR, I came to know the term point clouds. Mm-hmm. And could you please explain it to the general public listeners? What are point clouds?
So point clouds is just a whole lot of points. So a cloud of points. So by using this laser technology and doing that measurements at like 100,000, 200,000 measurements per second, you're generating a lot of points very quickly. So typically when we're in the forest, we're generating points of millions, billions of points. And when you have so many points together, it actually starts to look like a virtual forest or a virtual reality. So it basically is a concept. It's just a large number of points, so 3D points, X, Y, Z coordinates together.
Mm-hmm. So the 3D laser measurements. First of all, what are 3D laser measurements? How are 3D laser measurements, or visual forest, you also call it space twin, revolutionizing forest studies?
Yeah, so what we're trying to do is we're using the equipment, which is basically these terrestrial lasers, they're just surveying equipment. They're often being used not in forests. Their main applications is architecture, engineering, but also, for example, the police uses them quite a bit. So when there's a traffic accident, they will actually take these instruments, they will scan the accident in 3D. And by doing it this way, they can clear the accident much more quickly, which means there's quite a large economic gain. But essentially, we're all trying to do the same. We're trying to capture the reality in 3D. And the great thing about this as well is when we scan a forest and we have it in 3D, we can do virtual measurements in them. So we can virtually measure the height of the tree or the diameter of the tree or the shape of the tree. And what's also great is because we have the forest, we have the original data, the point cloud that you mentioned before. If there's something in the analysis that's not looking correct, we can always go back to the raw data, which is essentially giving you a real virtual understanding of that forest. Whereas with some of the other data that you collect in forest, you're in the forest and you take the measurements and you write them down on a piece of paper, which we then put in an Excel sheet. But if you then later realize this value doesn't seem very correct, there is no way of really checking that because the raw data is what's in your Excel sheet. So we're really trying to, with this technology, we're really trying to bridge of like measurements that we do in the forest. So we really go to forests globally with this instrument to how we can observe it from space. And what we're trying to do in our lab is using also radiative transfer, what you mentioned before, as basically a tool. So we take virtual models of forest, and then we also build virtual sensors in a modeling environment. So we can really try to link of what we can measure and see on the ground to how it's being observed by satellite data. Yeah, so they're not on now, but they're the same. So this is basically where the laser beam comes out and then collects like all the points, and then it turns around. So that's how it's been like basically capturing the whole 3D space. And then we can also put like a camera on top and a GPS, and then we have the internal batteries, so we don't have to have a lot of cables in the field, and then we just have them on a tripod, and then we just move them around in the plot.
As well, when I was preparing for this interview, I came across to know that you're working globally in different forests.
Mm-hmm.
I think it would be also interesting if you could name some of the research going on in across the world, perhaps for the listeners, just to mention.
Yeah, so we want to understand, well, the bigger picture of this is also, we want to understand how climate change or disturbances are impacting these forests. And it's a global understanding that we want to build. So it's not just me, we have colleagues all over the world that do similar research to this, or we collaborate a lot on this. So we're definitely not all going to all these forests globally ourselves. But there's a few countries where we have a strong presence. So Australia, for example, is one of them. So we've been working there for more than 15 years. It's a great country to work because they basically have all the different ecosystems in the world. It's logistically also quite simple to work, and we have some really great colleagues that we can work with. Recently, also Brazil. We got a few projects in Brazil and Peru and Chile, so South America. We definitely work quite a bit as well. And then with colleagues from the department, actually, Ghent University works strongly in Congo as well. So we've done some measurements there as well. And in the past, Gabon, Ghana, quite a few countries. We're trying to really capture these different variations in tropical forest, because tropical forest in Africa or in South America or in Australia or in Asia, it's not the same. Like, there's definitely differences in the structure of the forest. And actually, because of COVID, we also started to focus a lot more on temperate forests now. So we are have a nice project with colleagues in Germany. So we're working. We have a joint project where there are some sites in Germany near Berchtesgaden, so that's the German Alps, and then we have also sites of the same project in Belgium, in Bosland National Park. So in Belgium, that's where we work quite a bit. So Bosland also recently became a national park in Belgium, but it's a really great place to do research. We get a lot of great support from the people that manage a national park, from the forest managers. So it's really a nice interaction also because they're really interested in our research. And I think as a researcher, you also want your research to have some impact. So working together with them and trying to do research that can impact forest management is quite important as well.
And as well, I came across the concept of a StrucNet. I must say it's very much, when I was reading the paper, quite a big concept that you're trying to develop, and the global network for 4D monitoring of vegetation structure. Could you talk a little bit more about this idea?
Yeah, so StrucNet is well, you could call it a hobby project, sort of, but like a very advanced hobby project. So already during my PhD, we were trying to capture 3D data at regular intervals, but that meant that we had to physically go with a terrestrial laser scanning instrument to the forest and do the measurements. And we want to do a lot of measurements because we want to see how structure changes throughout the season, especially in Western Europe. You have the phenological cycle. And if we can get that kind of information over many, many years, and we can link that with some climate data, we can really try to see how differences in climate or temperature or humidity can impact the structure of forest. And especially, I think for a while, even in the UK, the leaf onset of leaves on oak trees was a climate indicator in the UK. But if you want to collect these data at regular intervals, and you also, you don't want to just do it in one location. You want to have a coverage to get an understanding of how these measurements translate over a larger area. And therefore, we've been working with colleagues in Western Europe, in the US, in Australia. Been basically trying out this new instrument. It's called LEAF. It's been built in Australia, and basically what it is, it's a laser scanner, terrestrial laser scanning, but you leave it in the forest on a fixed position. And then it's connected to a power box and a solar panel. So basically, it's designed, to be outside for a very long time. So that was clearly a challenge for the people that were building the instruments, because they are high technological instruments. So leaving them out all the time is definitely a challenge. And then, of course, we need to get power. And so we're using solar panels and batteries, and so far that's working. And we have a few sites equipped now. There's quite a few in Australia because the instruments was initially built in Australia, and people have been trying it out in various sites in Australia. And now we have sites in Germany, in Belgium, in Spain. Not all by us. We have a lot of great colleagues through the StrucNet network. So it's being co-chaired by Ghent University and GFZ in Germany. But we're only just starting. We equipped the first tropical site as well now. There's some plans to put some in Congo as well. So it's quite an interesting project because we put together a small steering group, and we're all about like the same phase in our career. So because of course the vision here is long term. We're not doing this to look at the data in 2-3 years. Of course we will for some smaller projects, but the real long-term benefit is here to have continuous time series of 10, 15, 20 years of how the structure of these forests is changing. And not just in 2D, we really have like a 3D, basically like a 4D. You have these 3D images over time, so you're creating this 4th dimension by time. So yeah, it's quite exciting to see where this will go in, let's say, 10, 15 years, and when we have all the data over a large number of plots.
Yeah, that's very much interesting as well. 4D, it's very ambitious, I must say. So can we use this 4D data to predict the carbon sequestration potential of forests, or carbon dynamics to be specific, under IPCC climate change scenarios? Or could it be perhaps, I'm maybe too ambitious here, simulate forest recovery times or destruction scenarios in the face of natural hazards? Perhaps it could be essential for managing risks in forestry, or any other potential implementations that I have not considered, and perhaps there is much more essential implementations to addressing some challenges.
Yeah, I mean, the answer to your question is probably yes, but So I think we can definitely do it if you collect TLS, so terrestrial laser scanning data at one point in the forest, and you go back in 5 years, let's say, the same site, and you can compare the trees. You can basically virtual weigh them or measure their height and diameter, and you can see how they've changed. So you can really translate that to what's been happening with their carbon storage capacity. The but comes in that we generally operate on quite a small scale. So what we do is we typically work on plots that are, let's say, 1 hectare, so 100 by 100 meters. So we know something in a lot of detail for a very small area of the forest. So for those areas, yes, you can definitely really monitor the dynamics of the forest in terms of carbon or recovery after disturbance. And that's what we're doing with Space Twin. But it's still a very small scale. And if you want to make that link all the way to satellite, there's a few ways that we can go. Like one of the projects that we're currently doing is focusing on multi-scale LiDAR, where we basically also mount LiDAR sensors on drones. So you go from terrestrial LiDAR, where you have a smaller area and you have super high density, basically that you have like real virtual reality forests, to drone data, which is covering a much larger area, but it has less points, so lower point density point clouds. So you're losing a bit of the detail of the trees. And then on top of that, we're now also using, together with other colleagues, helicopter LiDAR. So we also put LiDARs under the helicopter, which means we can cover an even much larger area, but again, at the cost of having less points per square meter. That's generally how we express it. And you go from 10,000, 100,000 points per square meter with TLS to maybe 300 points per square meter when you do it from an aircraft or a helicopter. So there's definitely this trade-off between like spatial scale and resolution of what you're seeing. So we're really trying to combine that to understand what's really going on a very small area to how we can extrapolate it on a larger area. So with that multi-scale LiDAR concept, we're trying to basically address this, because this is what really needed. We need to, forests, the structure of forest and the carbon sequestration, it can vary quite a bit. If you would have moved that plot of 100 by 100 meters, just maybe 1 kilometer to the east or something like this, maybe your results would have been quite different. So of course we want to not only understand what's happening in our plots, but we're also trying to understand the uncertainty on the larger scale of what we're trying to do.
Who came up with an idea of Space Twin, the name Space Twin?
So Space Twin is actually, it's the acronym of my ERC starting grant projects. So yeah, when you write these projects, they often ask you for an acronym. And basically, within Space Twin, we were very much focused on building these digital twins. Digital twin is definitely like a buzzword, and it's an interesting concept. I think it's important to really define how you see digital twin. So for us, it is basically in the context of rate transfer modeling. So we want to take these point clouds and we want to convert them into a digital twin. So we use a terrestrial LiDAR for the structural element of the forest. And then we also do other measurements like spectral measurements, for example, the leaves and the understory and the bark and the twigs, to basically give parameters to all these elements. So we're going to build a leaf, we're going to build a twig from the structural elements that we measure with 3D LiDAR, and then we're going to give it like spectral properties, because that's what we need in a digital twin, to basically do satellite simulation. So that's where the space comes in. So when I was writing the proposal, I thought, well, Space Twin sounds like a good acronym. So that's yes, and it's became like a bit like a little bit of an umbrella project, because I mean it's definitely one of the larger projects that we have going on, but we had a few other projects that sort of like focusing on similar or like related ideas around that, because of course it's a big idea and concept. But yeah, so Space Twin is an acronym of one of our projects.
Okay, so no relation whatsoever to telescopes.
No, absolutely not. The space is really, it's more related to the satellites that we use to look at the Earth, whereas with telescopes, you probably would want to look away from Earth. So yeah.
Okay. So you mentioned there a lot of terms that we use that are commonly also used today in research area. So perhaps it's a good link with my next question, just how knowledge and education is transforming in the age of big data and AI in terrestrial ecosystem studies. So, for example, have the skills required from perspective of master students and PhD candidates changed in recent years? For example, the basic data science and coding skills perhaps more required in recent years, or climbing, because I've seen some of the researches that you've been doing and are hiring professional climbers as well. Yeah.
Yeah. I'm not sure if the skills have really changed dramatically. We have definitely, I mean, in my team, we probably have now a wider range of profiles that we hire. So we specifically look for people with a computer science background, and not just, for example, people that are doing bioscience engineering or more an ecology kind of degree. So in the context of terrestrial LiDAR, and especially in the work that we do in the vegetation context, I don't think AI has magically solved all our problems that we have. I'm not sure it has really anywhere. It has just maybe made some processes more easy, or like it has made it more fast to analyze some of the data. I mean, we're still very like young community, like really operational use in forest with terrestrial LiDAR is maybe since the beginning of the 2000s. So quite a young research field. It's also not a research field where 20,000 people are working on this, maybe a couple of hundred people globally that are really working on this. I think one challenge is definitely also the challenge is basically, so in our lab, we want everybody to at least go to the field once, even if your main topic is all about AI and making really cool algorithms. I think it's very important to, I would say it's essential for anybody that works on anything with forest that we go to the field, that we see the trees, that we see the forest. Even like, I think it's a nice kind of area that we're in. Like we're not spending like 9 months or 10 months per year in the field, but everybody, or like most people, go out quite a bit, and it's not always very far. We also work a lot in the Ghent University forest, where we go at least once per month. So there are opportunities for people to go there and to maybe, you know, when you've been working so much just on the data and not even looking at it, sometimes it's just digital data. Like you say, it's big data. Sometimes it's good to just be in the forest and look at some trees and maybe, you know, put some perspective on what am I really doing, what is really going on here. So yeah, I think it's definitely exciting that we have this sort of wave of AI and deep learning and machine learning now. It's definitely also interesting to see where it will go. I'm not a big fan of just throwing everything into an AI algorithm, but I think it can definitely be very useful for some aspects of our research.
But overall, how do you think, as a scientist, what skills do you believe are essential for academic beginners to develop today?
Passion. I think if you have passion, I think it's probably the main. I mean, that is like the number one criteria. I think you can train a lot of different skills that are needed for your research, but if you don't have passion, if you're not like interested in then 4 years, the typical time of a PhD, can be quite a long time, because you're being trained, or like, you know, the goal is to be an independent researcher at the end of the 4 years. So it's quite new for a lot of people. There's no end date. The end date is in 4 years. It seems like a long time. but yeah, it's a training program as well. So it is definitely lots of opportunities to get a lot of new skills, and not just technical skills. It's also a lot of the soft skills are quite important. Learn to network, learn to ask for help as well. Like, of course, it's good to find your niche and to become very specialized in very something particular, but especially forest ecosystems there are so complex that quite often for the more complex questions we need to bring together anyway a lot of different expertise. So also having that skill set, or at least a mindset to like try to tackle problems together, I think it's quite important. Yeah.
Yeah. Thank you very much for just having some time to have this discussion as well, bringing in your own insights into the topic as well. I really liked your reply to the last question, that is passion. Of course, if you don't have passion and any skills that you have, you wouldn't be willing to implement in your research area, perhaps. So I do have some general questions for you to wrap up this episode, if you don't mind. I did share with you one, I will also show it in the screen, one article from Scientific America, titled "Greenery Improves Body and Mind." So I hope you read the article. So what is your personal experience and opinion on this article as a researcher who spends much time in greenery?
Well, actually, I haven't read it actually. So maybe if you can summarize it for me, I can give you my feedback on the summary.
Yeah, sure. So the general idea of the article is that we are somehow spend most of our time now in the confined areas, apart from the greenery. So, and there has been some studies that people who spend much time, perhaps in the garden or in the forest, in the parks, they have much more improved body performance as well as the mind. So they have more clear mindset compared to people who spend much of their time in perhaps in their room or in less greenery areas.
Yeah, I think that's definitely true. I mean, if I just think about myself, my personal experience of when I am out in nature, and it can even just be like, walking in the Bourgogne or a park in the city. It has a really positive effect on just your mental well-being as well. So I think access to green space is quite important, and it's actually interesting that you mention it, because we are really also doing a little bit of work around urban trees, working together with the city of Ghent as well. So I think in the coming years, we will definitely also have some scientific contributions to that. Because I think, especially people in our department, I think most people here, they are kind of nature lovers and they like to spend some time outdoors. And I think most people would agree that, being close to green, or like, spending time in nature. And like I said, it can just be a park in the city, or it can be a nice big tree people will have positive feelings about it. I think, it's definitely something that we need in our lives.
Yeah, I also posted jokingly on my Twitter that perhaps it's best the PhDs in forestry are having better PhD experience because just because they get to spend more time in greenery.
Yeah, possibly. I think people are, when we go to the field and people spend a lot of time collecting the data, which always sounds better for, it can be quite challenging. So a lot of our field campaigns, they are physically quite intense, and it's a lot of work as well. But I think overall, it's a great experience to be in these places. And sometimes we go to really amazing places that you wouldn't like normally be able to go. So yeah, maybe it's definitely true that I'm spending a lot of time during your PhD in the forest or in nature is it can definitely have I think it will definitely have a positive effect on you.
So what's your take on eco-anxiety, or also known as climate anxiety, and how to cope with it?
It's a very difficult question. I'm not sure I have a real opinion about this. I think it's really a problem that's probably exceeding like what we can really do about it. I think as a scientist, and even as a young scientist, it's as I think if we inform people correctly about what's going on and also what potential solutions that we can provide, I think that's definitely something we can contribute to as a scientist on a personal level. So I'm not too familiar, of course, with all the psychology about this, but I think a lot of times people are not super well informed about the real facts. So, and I think, especially in these days with a lot of misinformation, I think it's a bit our duty as scientists, of all of us, not just, the professors or whatever like this. It's everybody we can talk about what we know. Even though it might seem small or insignificant, because, for you, it might be small because you're working on this every day. But for a lot of people, this is, maybe new information. And I think, therefore, it's quite important that as scientists, we don't just do science and publish scientific papers, but that we also engage where we can on, for example, having a public talk somewhere, or just even talking with your family at a Christmas party, because maybe they probably think, oh yeah, what are you doing at university? Some science, but they don't often really know what you're doing. And I think, you can have a lot of small impact there. And I think if we all as scientists try to communicate well, I'm not sure it's going to really solve the problem, but I think this is something that we can easily do.
I couldn't agree more. So, and the final question, any advice for young students aiming to enter the academia?
Oh, there's quite a few. I think I always think it's quite important when you start a PhD. Well, I mentioned passion already, but I think also finding a good supervisor is quite important. I don't think you can, a promoter cannot be a good supervisor for every PhD student, I think. So I think it's quite important that you find a good match with somebody that can guide you through this process, because that's what it really is. It's a process of 4 years, and everybody has their own style or expectations, and you have as well. So I think it's quite important to find a match, and don't be afraid to ask some former students of what their experience was, because you don't always know. But don't be afraid to do it. It's not, you don't. I mean, you can ask for that kind of information. So I mean, open communication, I think it's also quite important. It depends a bit on the lab. So in our lab, we try to have very open communication, and we see each other as colleagues, and we try to learn from each other. I think it starts with starting your career in the best environment for you possible, or at least a good environment. I'm sure there's many great places where you can do or start your career. But yeah, ending up or starting your career in one of these places where you can have like a great experience, I think it's the start of a really good and nice career. I think in our department in general, we try to have this kind of, culture where you actually dare to go and ask for that kind of feedback, right? I think it's exactly saying what I was trying to describe before, that like through communication and not being afraid of asking for advice, because we don't know all the answers. You will never know all the answers, and knowing when or who to ask for advice, and either that being scientific or career advice or something completely different, I think it's quite important.
Thank you very much. Thank you very much for your insights and for this great talk. And I'm sure the listeners have enjoyed it a lot. And what I can say is that good luck with your research. And this is, when I was reading just a few of the papers, I've been very much inspired. And I'm very much happy to know that we have researchers who are working in these topics as well, implementing all the new technologies that are available there to solve tackling one of the biggest challenges for the, not saying for the country, but for the humanity. So thank you very much.
Thank you for having me.